In this video we're going to look at partial differentiation of the functional form. So if we had a function of this form here, x, y and y derivative, when we take the partial differentiation of this with respect to x, we keep y and y derivative constant. When we take the partial differentiation with respect to y, we keep x and y derivative constant. And when we take the partial differentiation with respect to y derivative, we keep x and y constant. So there's nothing new in that. So it means that if we were to look at all of the differentiation here, we're going to have 9 values. So for example, if we look at partial by partial x, so it's going to be partial x by partial x, it's going to be partial y by partial x, it's going to be partial y derivative by partial x. Similarly, we've got another 3 for this, so it's going to be partial x by partial y by partial y, and partial y derivative by partial y. And finally we would have our partial x by partial y derivative, partial y by partial y derivative, and partial y derivative by partial y derivative. So that's our 9 values there. So we'll have our first 3 here, and here's another 6. So these 3 here are straightforward enough. Partial x by partial x equals partial y by partial y equals partial y derivative by partial y derivative. These are going to equal a value of 1. Now this lot here, they're all going to be equal to 0. And you can see that if you were to pick just one of them, let's say partial by partial y. So we're saying partial by partial y, we know that x and y derivative act as constants, so we're differentiating the y derivative, but that y derivative, as we said, is just acts like a constant, so we're differentiating a constant with respect to y, which just gives us a value of 0. So best seen by example. Now you've seen the equation of a hanging rope whenever we derived that. So this has got part of the equation of a hanging rope here, 1 plus y derivative squared to the power of a half times y, but I've added a couple of extra terms. I've squared the y and added an x squared in. So let's go ahead and we'll differentiate this function here with respect to x, y and y derivative. So when I differentiate it with respect to x, y and y derivative act as constants. So that means that all we're going to have is the differentiating x squared with respect to x. This is going to give a value of 2x, and the rest of it remains fixed as is, as a constant. So if we look at the partial f by partial y, we're differentiating y squared with respect to y. That just gives us a value of 2y, and then the rest of it just remains as a constant. And finally, if we look at partial f by partial y derivative, the y squared and x squared just remain the same, so these are just stay out here. And if we differentiate this, we're going to have half of 1 plus y derivative squared to the minus a half, and then we just differentiate what's inside it. So we're differentiating y derivative squared with respect to y derivative, so that implicit differentiation is going to give us 2y derivative. So we've just got our 2's cancel out here, and we'll be left with our 1 plus y derivative squared to the minus a half times y derivative times y squared x squared. So that gives us the differentiation of this little functional form here. So let's look at another couple of examples on the next page. So I've already mentioned this one here on the previous page. If we looked at partial y derivative with respect to partial y, that's going to equal 0. And we can say equals 0 because if we looked at partial by partial y, we know that x and y derivative act as constants, so this y derivative is a constant. So that's the partial by partial y of a constant, which is equals 0. So let's say we had this example here, partial by partial y of some function p of x times y derivative. Then we can use the product rule, so we're going to have partial p by partial y times y derivative, plus, and we differentiate partial y derivative by partial y times p of x. So we can say that this partial y derivative by partial y is equal to 0. So this whole term here is equal to 0. So this whole thing is equal to partial p by partial y times y derivative. So that's all there is for this video. I'll get you in the next video. Goodbye.